Welcome Ji. Let's start Kotlin tutorial. Today I am going to discuss on the extensions. So what is the extensions, the meaning in Kotlin, and how Kotlin use the extension in the two form, in the form of extension function and extension property. So what the meaning of extension? Let's discuss. Extension is a kind of a ability to add the functionality in the particular class without inheritance or without intention patterns. So let's say we have a one class, and in this class let's say have a function 1 and function 2, and I want to add another function. So general the way we are receiving is that you just use the inheritance, just inheriting this two function and adding new one, and while creating the object of this class you have a three function available. So this is the general way to provide the uh, new functionality in existing classes. Sometime existing classes can be final, you have not option to inherit. In those scenario there is some uh, drawback, you cannot add the new functions or method inside existing class. So the situation where Kotlin say we have a developer have an option to extension function and extension property. So Kotlin provide an ability to extend a class with a new functionality without having to inheritance from a class or using a design pattern like a decorator. So this is done by a special declaration known as a extension. So extensions is a way to add new functionality inside a class without using inheritance. So that sometime you can write a new functions for a class from the third party library. They you don't have an option to modify that. In this situation also you can add the new function. So such functions are available for a calling as usual. They are a member. Okay. So when generally we have a use any method of an object using the dot method 1, method 2, method 3. Similarly, same way we can use extension function from dot operator, and this mechanism is known as extension function as well as, and we have option extension property as well as. So in short you can say Kotlin offer a facility to developer when you need to add new method inside existing library or your own class, but you don't want to, maybe that class doesn't allow to inheritance, but still you can. So this is the way. So let's discuss what are the syntax of how we can write extension function. So basically Kotlin extension functions provide a facility to add methods to a class without inheriting or using any specific design patterns. Create extension functions are used as regular function inside the class. So when you are added extension function without inheritance, and you can use same function as a regular function of these classes, and the extension function is declared using the prefix receiver types. So and also using the method name, that is extension function. So here example, let's see existing class name you are writing here using the, as you know, Kotlin say ki whenever you are writing any function or method, always start a keyword fun and then your existing classes on which you are going to add the new functionality, and here is the function name or your method names, and here you can define your function body whatever you want. So to declare extension function, the prefix its name with the receiver type. This is known as receiver types, and that meaning the type being extended, the which types, which object, which class we are going to extend. and you can use this keyword. Okay, this keyword is inside the extension function corresponding to the receiver object. So here, whichever object, let's say object 1, invoke this extension function. So this here, this keyword refer to the receiver object, so that you can access some property of the extended object as well. So let's look in one example. Okay, let's key write. We have a class like circle. Let's key we have a one variable radius. Let's it would double, and in this way, let's key one function like area. This return let's key to your double, and you define return your generally radius of a circle is equal to pi r square. Let's key method dot pi and r radius square, radius star radius. So in this way, now how can you create the object of a circle. Let's key 1 to your radius, and here you can use circle dot your area function. So this way, generally you first create the object, and whatever object contain the method, you can invoke those method. Here is area. So is it possible we can add like a c dot perimeter? We can add. Now I want to add the new method inside this class. Let's say this class is a final. By default, all class is the Kotlin is the final. You cannot extend. So how you are going to add the new functionality? So here Kotlin extension function help. So here you say uh, function. Let's key I want to circle class add a new function like a perimeter function. Okay, and what the definition? Definition would be that return this function, can we say return type should be double, and return should be like a 2 star math dot pi star your this dot radius. So exist this class object you can use this reference. So here now this C here function. Now whatever the C object you are invoking here, C object refer as a this here. Okay, and your function about it. So you are added new method inside existing class. Look like here ki C class have a two method, area method and perimeter method. If you run, you are getting the both method definition. So this is your concept of your, this is your, look like this is the ordinary method of a radius object, and this is your extension function. This is the not part of your class. This is the not part of your class. Still you are accessing like a regular method. So this the ability Kotlin offer, you can add new functionality in existing classes and library. Though this is the same example I explained, this is the circle class have one method, and here you can write your extension function like perimeter, and this is the class which you want to going to add this method, and what the definition. And let's discuss how it's actually managed. So extensions are resolved at statically. So all the extension functions are resolved is depending on the compile time itself. So extension do not actually modify class, they extend. If I am going to adding a new functions in that inside a circle method, so we are not going to modify the class. By defining an extension, you do not insert a new member into a class, but merely add a new functions callable with the dot notation on the variable of that types. So extension function are dispatched statically. So all the binding is done on the compile time statically. That means they are not virtual by receiver types. The extension function are being called determined by the types of expression on which functions is invoked, not the type of result evaluating the expression at a runtime. So sometime you have to like runtime polymer. This is the types of A, and you are assigning the type of subclass A, subclass B. So this is not a runtime resolution. This is the compile time, which the variable name are using the same class methods are invoked. Let us look at like example. Let us look like example. We have a one class like a shape. Let's see. I am going to another subclass like a rectangle. Let's key extend your shape class rectangle, rectangle extend your shape. Let's give it two class. We have a two class. So now let's key. I am going to if you are going to create a there is no any function that you can add extension. Let's key. I am going to add one function like a shape dot. Let's get name and name. I am just here passing like a name could be like println. That's key I writer shape shape ext extension function shape. Let's key similarly I have written a extension function for rectangle same. Okay, so here and now let's key we have one function. Now let's key we have one function like print shape. Let's key you pass uh, uh, variable s shape and here you are trying to say just this one. This s dot you just lay get name. You have a return function. Okay. So what happened? Let's see. You have write a print s shape, and here let's see. We have a let's get to have object ball shape. We have a shape object, and let's see. We have a ball rectangle object. Rectangle object. Here, if we pass shape object, so what do you think? They return a shape, or let's see what you pass the rectangle object. Then what do you think? This function print the this function or this function? So you know this is a return your shape. Why? This binding is here s dot name. S is the shape. So see, always they invoke the shape class method extension. They are not going to use your rectangle. If you want to pass a if you want to change here you want to change the rectangle or so here rectangle. If you want to use the rectangle here, so in this way, first your you pass rectangle, first they just print a new line. So here your save function, rectangle function, but here you passing both case R is rectangle subclass, but here you notice this R is passing rectangle, but this function take a shape. So get name is not resolved at a runtime. This is resolved at a compile time. Compiler name we have to invoke the get name of shape class. Here compiler no, I am going to invoke the get name of rectangle class. So this is the rectangle class, this is the shape class. So this is the you can say key all the extension functions are resolved at statically, not a runtime. Similarly, sometime let's give have a define the if a class member and extension member define the same as a receiver type. Like this is the class have a one function same and you define the same as extension function. So in this scenario, so member always win the members function always win. In this situation, always your let's say that is an example. Let's give we have a class example and here let's give we have a one function like foo1 and foo1 let's key println foo foo1 from example class. Let's key you define another extension function fun example class. Let's key define the foo1 again same foo1 same and here you say let's key println similar definition you can see here. Here let's key example of foo1 from extension function. Okay, and let's here say you create object of example here. Now here you can invoke e dot foo1. So here you have a two this is your one class itself have a foo1 method. You have added one extension function as well. So in this scenario they always prefer your member function. So extension function here words. So this is foo1 from class. This is from class. So let's print it then new line. So this is the from class. So be ensure that sometime you want to write extension function same signature as in the class itself. So this object always prefer its own functions, not your extension function. So let's this way you can add any number of your function inside your class. Here you can say in this class we have to add food2 food2 here food2 and here you can invoke e1 dot food2 also. There is no food2 here but you can add food2. So In this way, you are getting foo2 from extension function. So let's now discuss about how we can define as a extension property. So similarly like a function, Kotlin support extension property as well as. So which class name you want and the property name and the data types. But this is the problem here. This is the problem. One thing we have to notice: you can since extension function do not actually insert member into the class. Really, they are not in Kotlin not going to change your existing class. So there is a no efficient way uh, extension property to have a backing field. So we cannot define as a field. This is why initializer are not allowed an extension property. So you cannot directly initialize here. Let's say class name and the new property equal to this. So this is the not allowed. So how we can define the extension property? So this behavior you can only define using the provide the getter setter. Instead, we cannot add any new attribute field in this class, but you can provide getter setter. Through getter setter, you return your property. Let us example like let's give we have a class test. Test have a one variable property one. Okay, this is uh, okay. And let's do on it. Okay, let's int type. And now let's key I am going to add function. No, going to add the property. So variable let's key test dot property p2, and here is the data type your int. So what is the you have to provide initialize with the getter setter. So here say uh, here you say get and let's give value 200. Okay, let's keep p2 is deep and then they want to access let's keep multiply by your this plus this dot your p1 attribute. So in this way when this go inside value one object test equal to test and you are say let's key here there 50. So if you print ln t dot p1 you are getting a 50. Okay, we have only one variable, but you have options. You can as p2 at property 2 as well as property 2 is not a part of actually test class, but is the extension variable, and this variable is generally this what existing value a plus 200. So here 50 and 250. So this is the way you sometime you need you can add your property as well as. So this test class have a object and this object have a property 1 property 2 as well as, but actually this is only one property. So property 2 you are added functionality using the extension property. So this if you are trying to say if you are trying to clear like while here test dot p3 and equal to let's say define like 300 here. So here compiler not allow. Here say extension property cannot initialize because it has a no backing field. So you directly you cannot assign the value, but you can provide the setter getter for. Okay. So here you provide the setter getter. Now it works. So this way it's not allowed. And last sometime, companion object, sometime we are writing some function for a singleton. That function is a single copy, look like a static method in other language. So in this scenario you can add extension function for a companion object as well as. So if a class have a companion object defined, you can also define the extension function and property for the companion object. Okay, just like a regular members of companion object, you can call using the class name and the qualifier. All the companion object generally accessed by the class name. So from class name you can access. So here let's another example. Class, let's key my class. We have a let's key one function foo foo 4 have a like println my class foo 4 function. And you can also define the companion object, and here in companion object you can write one let's give foo 5, and here you can say println companion object object foo 5. So here we have option, you can add extension function for class itself, as well as you can add extension function for your uh, companion object. So in general, if you write here try to access my class dot foo, you can access their companion function directly here, but you cannot access like a companion from the normal function like a foo 4 here. Here you cannot access. Okay? And now foo 4 cannot resolve symbol. Okay, so companion object can access directly from your class name. Look like this is the static function, static method of a class. Okay, and the static, this is the enforce a singleton concept. If you want to access this 4 as old way, you can you have to invoke like we have to create object first, while m equal to my class, and after that you can you m dot you can have 4. So this is the minor differences. Here you can invoke function. So any companion uh, methods or functions are invoked directly from your class name, but normal functions are method of a class, you can invoke using the first object name that after your method name. So here we can write extension function for companion object as well as. So here is a write fun lucky you want to my class dot, if you here write a companion, then you can write your new foo 6, and here you can write println foo 6. So here again you can here my class dot foo 6 you can so you can add extension for your companion object as well as. So here the changes first your class name and then companion. You are going to add this foo 6 function inside your companion object. So this is the one kind of a tricky solutions. Some same class you can add a extension function for your normal method. If you add the normal method, then like if you say here you can add the fun my class dot directly foo 7, 4.7. So this is your 4.7. Okay, 4.7. So this is the 4.7. You can invoke from here. You can invoke m dot 4.7 as well as 7, right? 4.7. So very handy and easiest way Kotlin offer to add extension function. Just your uh, class name, plus the function name you want to add and the definition whatever you want. For companion object, you have to write a new that companion than your function name, which you want to add as extension function. Extension function. Extension function. Right. This is the extension function. Extension function. So in short, this is the way you can define. You can add extension function using the your fun keyword, the existing class name, the which function you want to add in the as extension, and the definition. For extension property, your property well and the class name, which property you are going to add, property name, data types, and you have to provide the data setter that you cannot assign. So this is the way, and similarly for a companion object, you can also add a companion here. So this is the kind of a brief about the extension function. This is very handy and a very helping tool Kotlin offer for developer. Developer can add new function, extension function inside the existing class, can add a property as well as, okay, without using the your any inheritance relationship or any specific design pattern like decorated design patterns. As a quick syntax Kotlin offer, you can add new function or method inside an existing class, and you can use same as your normal regular function. Okay. Hope it's useful. Again, I would like to say thank you for watching this video.